Hello viewers, welcome. Complex number and its operation we'll discuss now. The number of the form a plus ib, where ab belongs to set of real numbers r and I equals to root over -1 I square is equals to -1. It's known as complex number. And any complex number we denote it as z, where z is equals to a plus ib, and z belongs to set of complex numbers capital C. Like ab belongs to real number set, here z belongs to capital C. Now z is equals to a plus ib have two parts. A, real part of z, and B, imaginary part. But it is not actually imaginary, it is also exist, but real, as A is real part, we are defined as imaginary part. So there are two parts. That z is equals to 3 plus 4i. So here the real z is equals to 3 and imaginary z is equals to 4. Z is equals to -3 plus 4 by 5i. So here the real z is equals to -3 and imaginary z is equals to 4 by 5. The complex number z is said to be purely real if imaginary part is equals to 0, and a complex number is said to be imaginary if real part is equals to 0. So 4 is a purely real, but it is considered 4 as a real number. Now here 4 is a complex number, so 4 can be written in the standard form 4 plus 0i. Similarly, root 3i, it is purely imaginary and we can write in standard form 0 plus root 3i. Now conjugate of a complex number. Complex number. As we know, in case of real number system, 2 plus root 3 is a real number. So when it is multiplied by 2 minus root 3, we obtain 2 square minus root 3 square, which is equals to 4 minus 3 is equals to 1. So it becomes when a real number. So, and it is a rational number. So conjugate of 2 plus root 3 is 2 minus root 3. Similarly, a plus ib is a complex number, and when it is multiplied by a minus ib, the product becomes we apply distributive law here. ib into so a into a is a square minus abi in the next part plus abi, and then minus I square, that is minus I square equals to minus of minus 1. It is 1. So it becomes plus b square. So now we can cancel these two parts. So we are getting a purely real number. So conjugate of a plus ib is a minus ib. This is the conjugate of a plus ib. Two plus 3i is 2 minus 3i. Conjugate of minus 5 minus I is minus 5 plus I. So we are changing only the imaginary part, no change in the real part. Conjugate of I it is a conjugate of I. Yes, it is minus I. Now we'll start operations. First, addition. Z1 and Z2. Let Z1 is equals to A plus IB and Z2 equals to X plus IY. Here, the real Z1 is equals to A and real Z2 equals to X. Imaginary Z1 is equals to B and imaginary Z2 is equals to Y. So when we add Z1 plus Z2, we first add up real Z1 with real Z2 and then imaginary Z1 So this becomes a plus x, b plus y. So this togetherly say becomes a, and this becomes b I, where a is equals to a plus x and b is equals to b plus y, and both belongs to R. A and B both belongs to R, and becomes a standard form of two complex number. Okay, give an example. Let Z1 is equals to 3 plus 4i and Z2 is equals to 5 minus I. Now how to add? Now Z1 plus Z2 is equal to 3 plus 4i plus 5 minus I. So first, these are the real part. So add up 3 plus 5 plus next imaginary part 4 and here minus 1. Now 3 plus 5 is 8 minus 3i. So a plus 3i. It is in the form a plus ib. So this belongs to C. Now how to subtract two complex numbers? And we'll get difference. So if Z1 is a plus ib and Z2 is x plus iy, and real Z1 is a, real Z2 is x, and imaginary b, imaginary Z2 is y. Now we want to subtract. So first we write a plus ib minus Z2 is x plus iy. Ib minus x minus iy. Now like previous one, we first add up this and this. So it becomes a minus x. This is the real part plus b minus y. So if I take a minus x equals to cap a minus I b, where so this becomes a plus ib form, where a is equals to a minus x and b equals to b minus y. For example, Z1 is equals to 2 minus I and Z2 is equals to 3 plus 4i. Z1 minus Z2. 2 minus I minus 3 plus 4i. 2 minus I minus 3 minus 4i. Now 2 minus 3, a real part, plus taking I common, it is minus 1 and it is minus 4. 2 minus 3 equals to minus 1 plus I, and minus 1 minus 4 equals to minus 5. So you can write as minus 1 minus 5I. And this is the standard form A plus IB. So this belongs to set of complex number. Now division of two complex numbers. Z1 equals to A plus IB, and Z2 is equals to C plus ID, where Z2 not equals to 0. So Z1 by Z2 is equals to A plus IB by C plus ID. So when we will do the division, first we multiplied C plus ID with its conjugate. And conjugate of C plus ID is C minus ID. A plus IB, and as we are multiplying with C minus ID, so both numerator and denominator is multiplied with C minus ID. Now, we have learned that when you multiplied C plus ID with C plus ID and C minus ID, this together will get C square plus D square. So here we write C square plus D square, and the above we have to multiply A plus IB and C plus ID. So A multiplied with C minus ID plus IB multiplied by C minus ID. AC minus AID, then IBC minus into minus, so minus I square is coming, minus I square B into D, and I square is minus 1, and with product of minus 1 it becomes plus 1, so this becomes BD. So we write here BD. Now AC and BD equals to, add AC plus BD plus I minus AD plus BC. C square plus D square. So this is equals to AC plus BD by C square plus d square. This is purely real part, and then BC minus AD square plus d square. So this we can take as x plus I y, where x and y both belongs to real number, and x plus iy belongs to complex number. So here is the example for Z1 and Z2. Okay, thank you. For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.